Hi there, let's deal with the periodic table in our chemistry unit, which is sort of topic 4, I think. To do that, we need to do a bit of review on what an atom is. And so, a couple important things to consider about atoms. On the periodic table, elements have something called a number. It's called the atomic number, which stands for the number of protons, and in the case of an atom, because it's stable, the number of electrons. What about the number of neutrons? Are they always equal to the number of protons? No, not in every case. So how do we find that? We take the mass number, which is we average it, and that's equal to the number of protons plus the number of neutrons. So you subtract mass number from number of protons to get the number of neutrons. So here's fluorine, for example. Fluorine's number 9 on the periodic table, which stands for the number of protons. And here's its relative atomic mass, and we have to round it to 19. So how do they get 19? Well, 19, which is the mass number, is the number of neutrons plus the number of protons. So if fluorine is 19 and its atomic number is 9, we subtract the 2 to get 10. What is 10? 10 is the number of neutrons in fluorine. Let's talk about a pattern. If we were to draw atoms of lithium, sodium, and potassium and compare what they looked like, here's what we would see. Lithium would have 1 electron in its outer valence shell. Sodium, if we drew it, would have 1 valence electron, and potassium would have 1 valence electron. And the reason for that is they're in the same up and down column in the periodic table, which means that they're very similar to each other in the way they behave and react. Same with helium, neon, and argon. They all have what's called full valences. Helium has 2 electrons in its outer shell, which is full up. Neon has 8 electrons in its outer valence shell, which makes it full, and argon has 8. Because of this similar electron arrangement, they're in the same up and down column, and they're part of what we call a chemical family. They're the noble gases. So let's look at how the periodic table is arranged. There are certain patterns we need to know. Most of the periodic table is made of metals, which are located to the left. There are some nonmetals, which are located to the right on the periodic table. And then there are some substances called metalloids, which behave sometimes like metals and sometimes like nonmetals. I just drew something called the staircase, and the staircase helps us outline which are metalloids because they touch the staircase. Dmitry Mendeleev, a Russian, was the first to understand and arrange the elements on the periodic table according to the atomic number. For example, there's the atomic number. Remember what that stands for. It stands for the number of protons in the nucleus. Now, when he arranged them, what happened was he started to create different families that we now need to know. For example, sodium, potassium, etc. These are all alkali metals, and they're fairly reactive due to that 1 valence electron. Beside them, these are all alkaline earth metals. Calcium, for example, is in here. And they all are on the same family, or group is what it's called too. Then over here, halogens, fluorine, bromine, chlorine, they all have an almost full valence. So they're missing just one electron and it would be full. So they're part of the halogens, and these have full valences. These are unreactive, and they're called noble gases. So here it is again. Vertical columns are called families or groups. Horizontal columns this way are called periods on the periodic table. And here's our staircase, which helps tell us which ones are metalloids. Aluminum is not a metalloid. So out of your textbook here are the chemical families. Alkaline metals, they get more and more reactive as you go down. So francium is one of the most reactive metals. And these are the alkaline earth metals, and they get more reactive as you go down as well. The halogens go the other way. They get more reactive this way. And the noble gases are unreactive due to the full valence shells. We did this lab to see if we could find out properties between elements on the periodic table. And we can use a periodic table to tell us whether it's metal or non-metal. And here's what we found out. Aluminum. So most metals conduct electricity. Most non-metals do not conduct electricity. Most metals are malleable, which means we can bend them. And most metals are shiny for luster. Most metals are solid at room temperature. And most react with acid. So in general, here are some properties that we should know that differ between metals versus non-metals. Metals are good conductors of electricity and heat. They are bendable or malleable in their solid state. Most of them show a metallic luster, have a high density, and they're solid. It's at mercury at room temperature, and they're reactive to acid. Whereas non-metals, they're less reactive. They could be solid, liquid, or gas. They do not possess a shiny metallic luster, and most non-metals are poor conductors of heat and electricity. Let's look at the brain pop clip on metals and non-metals and the periodic table.
Dear Tim and Moby, please make a movie about the periodic table of elements. From Lauren. Sure. You're overreacting. It's not that complicated, really. The periodic table of elements may look complicated, but considering it's a list of all the chemical elements that occur in the universe, and then some, it's actually pretty simple. It categorizes elements according to the properties of their atoms. Atoms, you'll remember, are the smallest unit of an element. They're made up of a nucleus composed of protons and neutrons, and a number of electrons orbiting in different shells, or orbitals. It's the numbers of protons, neutrons, and electrons in an element's atoms that determine its properties. That's right, Moby. The configuration of these three particles is the only thing that makes one element different from another. The modern periodic table of elements organizes elements so that it's easier to see how elements relate to one another. Well, first off, the elements are listed by their atomic number, or number of protons in their atomic nuclei. You can find that here, along with the element's symbol, name, and relative atomic mass. You can read across the table this way. Hydrogen has 1 proton, helium has 2, lithium 3, beryllium 4, boron 5, and so on. Reading across this way, the sets are called periods. You remember how electrons orbit in shells, right? Well, periods describe the number of electron shells that elements have. Period 1 consists of only 2 elements, hydrogen and helium. These guys only have 1 electron shell. Period 2 contains elements with 2 electron shells. The first shell contains 2 electrons, and the second one can hold up to 8 electrons. As you read across a period, that outer shell fills up with electrons. So lithium has 1 electron in the outer shell, beryllium has 2 electrons, boron has 3, and so on. By the time you get to the far right side, the outer shell is completely full. The 6th and 7th periods contain so many elements, scientists took some out and put them underneath. Well, the configuration of electrons in an atom's outer shell plays an important role, too. It determines what other kinds of elements it can bond with. On the periodic table, elements with similar configurations of electrons are arranged in vertical columns called groups. Groups are numbered 1 through 18. In some of these groups, the elements don't have that much in common, but that's not always the case. Take a look at group 1. All the elements in this group have exactly one electron in their outermost shells. That means they're likely to form positive ions. They're also likely to bond with elements in group 17, whose outer shells are one electron shy of being completely full. The periodic table is also organized by color into different categories. These categories are organized by properties of the elements. Alkali metals, like sodium, all can react with water to produce alkaline solutions. Alkaline earth metals, like calcium, also produce alkaline solutions when combined with water and are found all over the place on Earth. Transition metals, like iron, are strong and shiny. Poor metals, such as lead, are soft with low melting points. Semi-metals, like silicon, conduct electricity only under certain conditions and are useful in electronics. Nonmetals have a variety of properties and include the carbon, nitrogen, and oxygen vital to life on Earth. Noble gases like helium and neon have outer electron shells that are full, and so they don't often react with other elements. So there you go, the periodic table of elements.